So in the next scene here, we're going to look at rigid bodies, rigid body particle simulations using ice. And what I have here is a series of chairs, and I have a force, a little null, coming from this null point here, that's going to make these chairs kind of fly out and then hit the other chairs, causing a cascade effect. And if I just play this, you'll see those first two chairs get pushed out, and then they hit the other chairs, causing like a domino effect of chairs. And we can move around a bit, and you'll see kind of how they're colliding. If we look from an angle, you'll see it's using what considers convex hull collision. So the chairs are colliding, but they're not entirely realistic. So this one here is kind of sitting on its back. So mostly it looks okay, but if you look at closely, you'll notice that not everything is colliding in the way you're predicted to collide. You know, they may not have the same balance that you would expect something to hit if it's actually using object shape or concave hull. So it's using convex hull, and what that means is that it's pretty much like a modified bounding box around the object. If we look at this chair here, just going to stop the animation for a second, and I actually modeled what would look like a convex hull shape, and this would be more of a convex hull style shape. If it was a sphere, it would work quite well. If it's an object that has any concave areas such as holes, or a torus shape, or a C shape, it wouldn't work quite as well. And that's why the area inside here, this area is considered concave, therefore it's just going to look straight between those two areas. Same with underneath the legs. The chairs wouldn't stack because there's going to be a solid area underneath the legs. So this is the effect, and the ice tree that defines this and builds it up uses a bunch of systems. We actually have, we're not emitting from this object, for the reason is this object, if we emit from surface, the points will be emitted somewhat randomly. I actually wanted to have the chairs ordered, so I actually use this object to organize the chairs. If you go back to the first frame, you can see how all the chairs are sitting nicely on the grid, like a theater. And I've done that by using emit from position, and then emitting them based on the point position. Of course, there's points we don't want to emit from, so the points back here we wouldn't want to emit from. So in that case, we've actually got a weight map on this grid, and we can see that. See the weight map I've painted, and the weight map is used to define which points it's going to emit from. Now, of course, those points are on the edge. Again, we didn't want that, so I've actually gone a little add node here to shift the chairs back and across slightly, so they don't actually sit on the edges. I could add another row of points in there if I wanted to, but I just thought it would be easier this way to shift, and so you can place points at emit time by using add nodes. Next here we are using instant shapes. Instead of using a shape such as a box or anything else, if you disconnected this, you'll get the shape again, and you can pick what shape you want, point, these different shapes. But if you actually connect a instant shape node to the shape, you can actually change the instant shape, and we're using our chair object that's called polymesh 1. And those are emitted, and it's using turn this weight map off. It's using the center of the point as well, so each of them have the center placed at the bottom. You have to be careful when you're using instances, especially of rigid bodies, to make sure the center is inside the object, not outside, because it can cause some strange reactions found. Next, we're driving the particles. We have a gravity force, so they actually don't fly up into the air. We may want to decrease this gravity a bit because I may want them to fly more. And we have a point force that's pretty powerful force pushing them away, only using a cutoff distance of 50, and that's really only a distance of about 2 chairs. So it's only really pushing a couple of chairs right here next to this block. So just move this across a bit. So it's really just moving these two chairs, and they're getting pushed out and up a bit, as we can see when we hit play. And then those chairs are pushing the other chairs, with pushing the other chairs, and then everything is cascading down. We move this down more. If we want underneath the chairs, we probably have them blow up more to give it a different effect. And I think we're going to lose this chair over the edge. This is when you probably want a bit more gravity or a bit less force. So you can shift this around and get different effects as you need. You may notice some strangeness happening. Sometimes if two objects intersect, then you're going to get a little kick as the particles push away from each other. It's just something that happens in rigid bodies. So you want to make sure the particles aren't intersecting at the beginning, because they can have more kind of rapid and erratic motion if they start by hitting. So if you ever see particles fly off randomly at high speed, it may be due to an intersect error. Okay, so let's go ahead and look at how we build this up from scratch. Now I've looked at all the nodes. Last of all, we have a collision group here. So because it's convex hull, we also can't use this object here as a collision object, because it would just be like a standard slope that just slide down over the effect and wouldn't hit on individual steps. So we have these series of objects, as you can see, what I call collision objects, and they're just a series of planes. And you can group all the planes together, and here's my collision group, and then link this in to your collision object. You can also have multiple collision objects built in to simulate rigid bodies. And the main differences between simulate rigid bodies and simulate particles is rigid bodies allow the particles to collide with each other, versus just standard simulation of particles, the particles won't stack and they won't collide with each other.